Hi everyone, we'll continue with the previous class. That is analysis of second order system. Okay. Now this is a response of a second order system. Step responses for second order systems for various damping ratios. Right. So when there is no damping, okay, the damping ratio is zero and no damping is applied, then the response is completely oscillatory response you will get. So it is moving, it is oscillating from ups and downs. You are seeing this is undamped. Then if the damping is applied, okay, if damping is applied, then the system behaves, uh, it oscillates in the beginning after a particular time when it comes to steady state position. That type of damping we call it is critically damping. Next, when the zeta value, okay, when zeta value lies between 0 to 1, we call that type as critically damping. When the zeta value is greater than 1, it is over damped system. See here, before reaching the final value, it is lower than final value. It is not reaching the final value. It takes much time to reach the final value. The race time is so high for overdamped system. Next one, see the zeta value. When zeta value is between 0 and 1, the transfer function is given by g of s is equals k into omega n squared divided by s plus zeta omega n plus j omega d into s plus zeta omega n minus j omega d. Right, where omega d equals omega n into square root of 1 minus zeta squared. Right. So this is my transfer function CFS. The root, there are two roots, omega n plus or minus root of 1 minus 0 squared. It lies in, it lies in second quadrant and third quadrant. Plus j omega n, it is in second quadrant, minus j omega is in third quadrant. Okay. Right. Then we look upon a time domain specifications. First one is delay time. What is delay time? It is the time taken by the response to reach 50% of final value. We call it as a delay time. In this graph, so here at this point, this is the point we call this as a delay time, right? We'll take in okay. Right. So this position, okay, we take a critically damping system. Okay, this is my final value. This is my final value. And, okay, right. So this is my final value because it settles down. This is 50% of final value, right? So here this time, the time taken reach 50%, we call it as delayed, right? Right, TD, right? Then what is raise time? Okay, the time taken by the response to reach final value. This value we call it as raise time. So here this point is T R. Then what is TP? Peak time. Okay, the time taken by the response to reach peak values. This is my peak value in critical time system. This is my peak value in undamped system. Right. So the time taken by the response to reach peak value. Okay. So here this time we call it as TP. That is peak time. Then what is settling time? So here the system settles at this point. It reaches steady state at this point. This time we call it as settling time, TS. In time domain specifications, we discuss one of five definitions. One is delay time. One is delay time. Second one is rise time. Third one is peak time. Fourth one is settling time. And final is peak overshoot EMP. Then what is this MP? It is the difference between maximum value and final value. This value here, this value is peak overshoot. Okay, the difference between final value and peak value, we call it as peak overshoot. Okay, peak overshoot. These are some of the definitions of time domain specifications. Okay, we erase those things. Okay. Right. Yes, we take the point. Right. So here, this is my rise time. This is my delay time. 1 second. So here, this is my rise time. This is my delay time. This is my peak time. This is my settling time. This is my peak overshoot. So here, the allowable limiter is 22% tolerance. So this is my tolerance. Okay. Thanks for watching. Thank you.